This is the third and final lesson of the unit. This is called the method of trigonometric substitution. Okay, so what is involved in this particular method? If you see an expression a squared, so some number squared, minus x squared, in this method you will let x equal a times the sine of theta. Okay, if you see the expression a squared plus x squared, then you will let x equal a tangent of theta. So theta is just a temporary placeholder, and you'll see how that works momentarily here. X squared minus a squared, and that's going to be let x equals a times the secant of placeholder theta. A large majority of the time you will see one of these expressions here under a radical. So this is what you have to memorize. This substitution, these substitutions right here. Another thing that you should know coming into the course, but we're going to review it, a couple identities. The sine squared plus cosine squared obviously equals 1, sort of the standard. Now suppose you divided every term here by the cosine squared. Well, then I would get tangent squared plus 1 equals 1 over cosine squared, which is secant squared. So there's another identity. Go back to this original and divide every term by the sine squared, and we get 1 plus cotangent squared equals cosecant squared. So that we have 3 additional identities. These are identities that you should know, and these are new substitutions that you should memorize. And I'm going to give you 3 examples utilizing each of them. Here is example 1. The integral of 1 over x squared times radical 16 minus x squared. And by the way, this is my favorite of the types. I really enjoy it. Alright, so we see the expression here. Here it is. That's the expression a squared minus x squared. Specifically, 4 squared minus x squared. Alright, because of that, we're going to say let. We're going to let x equal a, which is 4, times the sine of placeholder theta. Okay, a really important step here is to now find dx and d theta, how they relate. So the derivative of x is dx, and the derivative of 4 sine theta is going to be 4 cosine of theta d theta. That becomes very important in our substitution also. Okay, here we go. We're going to plug everything in. So the numerator is dx, and we just found that to be 4 cosine of theta d theta. X squared is going to be 16 sine squared theta. And then we have the square root of, let's extend this a little bit here, that's going to be 16 minus 16 sine squared theta. So all I did here was plug in once I made this substitution. Let's do some simplification. Well, initially I see that I have a 4 over 16, so that's nice. But the 16 inside here I want to factor out. So I'm not really factoring out a 16, I'm factoring out a radical 16 because it's under the radical. When I pull out a radical 16, I'm really pulling out a 4, and that's going to cancel out with the 4 that we see here. So we are left with, let's write it like this, the cosine of theta d theta over, we still have this 16 sine squared theta, and now we have the radical 1 minus sine squared theta. In all these problems it's similar. The part under the radical can be substituted with an identity. So let's see, cosine theta d theta on the top, 16 on the bottom, sine squared theta on the bottom. But inside here, this is really the cosine squared of theta. So now we have radical cosine squared theta, like that. And then the square root of cosine squared is simply cosine, which will get rid of the value in the numerator. So we have d theta in the numerator, 16 sine squared theta, and then again over here this canceled out with this. And we have 1 over 16 times the integral, so 1 over sine squared is really cosecant squared theta, d theta. And in terms of theta, this is a good old-fashioned book of memoirs. Memoirs, 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 memories. Here it is. 1 over 16. This is going to be negative cotangent of theta plus c. You have to be ultra careful. A lot of people prematurely, immaturely say this is the final answer, yay, and they put a box around it and then burst into tears later to learn that this is not the correct final answer. See, we have this in terms of theta, but we want it in terms of x. Alright, let's come over back to where we did our initial substitution. In our initial substitution, we said let x equals 4 sine theta. Another way to write that is x over 4 equals the sine of theta. So I draw a right triangle and I make a theta. There she is. And then we say that the sine of theta is x over 4, opposite over hypotenuse. And then my missing side is simply the other leg, which is going to be 16 minus x squared, like that. So this helps us to establish a relationship at the bottom. So we have negative 1 over 16, and I have to say, well, what is the cotangent of this angle theta? What is the cotangent? Well, it's going to be adjacent over opposite. So the adjacent over the opposite, and all of that plus c. And now you can celebrate with a good old-fashioned BOX around the answer. Let's take a look at number 2. No, silly, not that number 2. This number 2, right here. The integral of dx over the square root of 4 plus x squared. This is a good time to press pause and try it and see if you can get the answer. Okay, here we go. I see the expression a squared plus x squared. Specifically, 2 squared plus x squared. So I know I need to make a substitution. Let x equal, do you see what it should be? A, or 2, times the tangent of theta. And while I'm here, I'm going to find dx to be 2 secant squared theta d theta. Alright, I'm ready to do some substitution. For dx, I have 2 secant squared theta d theta. And then in the denominator, I have 4 plus, so I'm going to square x, so I have 4 tangent squared theta. All right, so 2 on the top, not that too silly, and I'm going to factor out a radical 4, which is going to bring a 2 down here, and I have a radical 1 plus tangent squared theta. The 2's cancel out. Do you see this? This is kind of the trick that happens with all of them. This turns out to be something nice, and it turns out to be secant squared theta inside the radical. So I have secant squared theta d theta on the top, and the bottom I have the square root of secant squared theta. I'll jump down over here, and so I'll have secant squared over 1 secant, which gives me a grand total of secant of theta d theta. If I only knew what the integral of secant of theta d theta was. Oh, Jeremy! Oh, Jeremy! Are you thinking Jeremy Lin? If not, then you have no idea what I've talked about in the past, and a little joke that a student has helped me to memorize what the answer to this is. Oops. That's an accent, as in dave. Not needed here. Equals, the integral of secant theta is natural log absolute value secant of theta plus tangent of theta plus c. Okay, don't be that guy. We don't leave this as the answer because I have thetas in here and I need to put it in terms of x. So that's when it calls me to draw the triangle. So x equals 2 tan theta, or x over 2 equals tan theta. Draw my right triangle. Draw my theta. And opposite over adjacent is tan theta. So my missing side is going to be the square root of, let's see, 4 plus x squared. There it is. Alright, my answer down at the bottom. Natural log, absolute value. So the secant of theta, well, cosine is going to be 2 over radical. And so the secant is going to be the reciprocal. 4 plus x squared over 2 plus, now the tangent of theta, well, we already said what that's going to be, x over 2 plus c. If this is your final answer, I'm very happy, although it actually could technically be simplified further using properties of natural log. We could say this is the natural log of absolute value 4 plus x squared plus x plus c, because if I had this as a common denominator of 2, I could say natural log of minus natural log of 2 plus c, and then this is just some other c. So this here, my friends, is the final answer. Final example, example 3, actually the final example of the entire unit. Don't cry for me, Argentina. Anyway, here we go. Perhaps you want to press pause and complete the problem. See if you can. This one gets a little bit tricky at the end. Whew, you know, when you stare at a screen and talk to yourself long enough, you do begin to go a little bit crazy, such as I. Anyway, we have the expression x squared minus 3 squared. Okay, so I'm going to make a substitution. Let x equal 3 times, you guessed it, secant theta. We find our dx, which is 3 secant theta tangent of theta, d theta. There she is. And we're at the substitution stage. Alright, so in the numerator, I have x squared minus, no I don't. I have instead 9 secant squared theta minus 9. There we go. And then the denominator, I have 3 secant theta. And now I have my dx, and my dx is 3 secant theta tan theta d theta. Alright, right off the bat, I can cancel this with this and this with this. I'm going to jump down below here. I'm going to factor out a radical 9 to get a 3. Square root of secant squared theta minus 1 and tangent of theta d theta. There we are. That looks like it. Inside the radical, this becomes tangent squared theta. So I have radical tan squared, which is just tan, together with another tan, very tan, I get tangent squared theta. Again, that's a tan here and a tan here and a tan here to get tan squared theta d theta. Now this is no walk in the park here. This is actually a bit tricky. I don't have a book of memories for tangent squared. I do have a book of memories for secant squared. So if I could somehow make this look like secant squared, and I will through an identity. So this is 3. I can write this as secant squared theta minus 1. Okay, because that's what this equals. Secant squared theta minus 1 d theta. Okay, so I'm going to break this into 2 separate integrals. 3 times the secant squared theta d theta minus 3 d theta. See that? I distribute the 3 and also distribute the d theta and separate it. Sum of integrals is integral of sums. Okay, so what do I have here? 3 times book of memories. So this is 3 times tangent of theta minus 3 times the integral of d theta with respect to theta, or 1 d theta. So the integral of d theta is just theta plus c. Okay, there it is. There's the theta portion. We still have everything in terms of theta. We're in the substitution stage. X over 3 equals the secant of theta. Draw my triangle. Theta. Secant of theta. Well, the cosine is adjacent over opposite. So this is going to be x here and the 3 here, the reciprocal. And the missing side, x squared minus 9. There we go. Okay, coming down below again, 3. The tangent of theta then is going to be the square root of x squared minus 9 over 3. And now what is theta? So the only way we can find theta here is to call theta the inverse secant of x over 3. So this is times the inverse secant of x over 3 plus c. Final answer, let me scroll. The final answer, radical x squared minus 9, cancels out like that, minus 3 inverse secant x over 3 plus c. That is the end. This is the end. My simple friend, the end. Okay, hope you enjoyed it. The practice problems will be given in class.